Concepts related to motion in 2 dimensions. Concepts of motion in 2 dimensions. So the first question for you, true or false? If we're going to fully describe a vector quantity, you must state both the magnitude, the size of the vector, and the direction of the vector. That is true. So we'll just circle true up here. A vector is completely described if we know the size, the magnitude, 5 meters per second perhaps, but that's incomplete. We need to tell the direction. 20 degrees from the x-axis, positive x-axis, etc. Okay, second one here. A scalar quantity has an associated magnitude and direction, a scalar quantity, and that is false. Scalar quantities don't have a direction. 6 kilograms. That's not 6 kilograms to the east or 6 kilograms at 30 degrees. It's just 6 kilograms. So there are magnitudes for scalar quantities but not direction. Vectors have magnitude and direction. Force, velocity, acceleration, those vectors have magnitude and direction. So if we have a vector here A, and for some situation perhaps we need minus A, the vector minus A. How is minus A different from A? Well, to draw minus A, I simply reverse the direction. So if I want to draw it starting at the origin, and I'll do this freehand, so I hope it comes out reasonably close. Here's minus A. That's how it would look on the diagram here. The length of minus A is the same as the length of A. So the lengths are equal. The angle for minus A, I just add 180 degrees to the angle of A. So let's suppose this is 30 degrees. The angle for minus A from the x-axis would be 210 degrees. So the angle of minus A is 180 degrees larger than the angle of A. And if you go past 360, you'll have to adjust that, subtract 360. Or you can say it's opposite. The direction is opposite. But that's the vector minus A. An object's moving in both the x and the y direction, so we have projectile motion here, and we have some change in the velocity in the x direction for some reason. And the statement here is this is going to cause a change in the acceleration in the y direction. So we're making a statement that we have a change in the velocity of the x direction affecting the acceleration in the y direction, and that is false. The x and y motions are independent. X and y are independent. You have to work them as 2 separate equations. So x and y motions are independent. Motion in x does not affect motion in y. In addition, velocity never affects acceleration. So for 2 reasons, we've got a false for this. Number 5, last one here. Air resistance is ignored. We've got projectile motion and moving in x and y. If air resistance is ignored near the surface of the Earth, the value of acceleration in the horizontal direction is 0, while the object is traveling through the air, not in contact with the ground, so no friction, and we're ignoring air resistance. What do you think about that statement? And that is true. And that leads to simplifications in projectile motion problems, in that we can just use x equals the original velocity of x multiplied by time in the air, and that will produce our new x position. Distance equals rate times time. Distance equals rate times time. There's only one equation in the x direction for projectile motion. In the y direction, you'll have the full set of kinematic equations that you have to select from. So I hope you've reinforced some of your concepts here for motion in 2 dimensions. Ask your instructor or other students if you have questions.